In this video, we're going to be covering managing devices via an operating system. We're going to be looking at some of the commands that we can use to get information on our devices, as well as looking at some of the locations on the system where we can find our devices. There'll be a little bit more information in there too. This is going to be a bit of a long one with a lot of information, so settle in. Continuing with the VM that we installed in a previous video, as well as pulling in my physical server and Intel NUC for further information, we're going to be taking a look at things like the /sys directory, the /proc directory, and the /dev directory. We're also going to take a look at things like loading modules or kernel modules, and a little bit more. So let's get going. The first command we'll cover, and I'll do this on the VM and the server to show the difference between the two, is the ls-pci command. So I'll run ls-pci on the VM first. And as you can see, there isn't an awful lot here. This is all just virtualized hardware. We have USB controllers, Ethernet controllers, VGA compatible controllers for visual stuff, SATA controllers for disks, and a few other things. If I now jump over to my physical server, I won't bother with the Intel NUC on this one, and run ls-pci, you can see now we have a lot more devices. So we have, again, USB controllers, we have the RAID bus controller for my storage, another USB controller, another RAID bus controller, memory controller, Ethernet controllers, and much, much more. A PCI device is essentially just a card, usually, that slots into your motherboard. A graphics card would be a good example of this. PCI just stands for Peripheral Component Interconnect. For the moment, I'm going to work with my RAID controller. So if we take a look up here, we have this RAID bus controller and another RAID bus controller here. And just to filter this out a bit, I'm going to pipe it through grep, just so I can see the two that I want. Now let's have a look. We've got the Intel Corporation one, and then the HP Smart Array one. Now, this one here is the built-in RAID controller that's on the motherboard itself. This one here is my dedicated RAID card. So I'm going to work with this one. We'll take a look at this bit here, and this is the device ID. We can use this device ID to get more information on the PCI device itself. So I'm going to go ahead and run ls-pci -s, the device ID, which is OA00.0. And then I'm going to put -v on the end to print it out verbosely. And there it is. In fact, I'll just quickly show you without V as well. There it is. It's just the same as the single line that we saw before. So taking a look at the -v one, we have the subsystem itself, the physical slot that it's plugged into, so that's the actual PCI slot, some memory information, the I/O ports, the expansion ROM, the capabilities of the card, and the kernel driver and modules in use. We can get just the kernel information if we want by changing the -v to -k. There we go. Same details, but just a little bit more compact. You may rightly be asking, but what's a module? A module is just a way of extending the kernel. It means that we can do things like load those PCI devices or load drivers for those PCI devices dynamically or on demand. It prevents us needing big, huge monolithic kernels that can support every single possible device that would ever be used with a system. It means we can have small kernels, and then if we have a new piece of hardware, such as a RAID card, we can just load the module for that RAID card. That allows us to have small kernels that can be dynamically extended. Let's type lsmod and take a look at the modules that are enabled on this system. We will see the HPSA module that's listed there. So if I just scroll up a little bit, we can see all the modules that are enabled on this machine. And there's a lot here. There's things to do with networking, IP tables itself, and much, much more. But we're interested in the HPSA one. So let's just see if we can quickly find it. And if not, we'll filter. There it is. So displayed here is the module name, the amount of memory it's using, and the number of dependent modules. If you see something afterwards, like here, this means this module relies on that module. So if we take a look at the SCSI transport SAS, you can see HPSA here. So this relies on the HPSA module. We can enable or disable a module using mod probe. if we want to remove a module, we can do modprobe -r HPSA, for example. For the record, this will not work because the module is in use, so I'll run that, and there's the error. Fatal, module HPSA is in use. If the module wasn't in use, then it would just remove the module from the system. In a scenario where you cannot remove the module because it's in use, we would need to disable them on boot. So, as an example, there is a module called Nouveau, and this is used for NVIDIA graphics cards. It's essentially a replacement for the proprietary NVIDIA drivers. I don't have it enabled on this server, but we can still get information on it by running modinfo -p Nouveau, which is spelled Nouveau, if I remember correctly. Yes, it is. So here we can get information on it. As I say, this isn't enabled. There's nowhere in this list. In fact, I'll just prove that fact real quick. So I'll do lsmod grep Nouveau, which I just spelled Nouveau. I have to remind myself every time. And there you go. It's not there. It's not enabled. So again, let's take a look at it. We've got this here. So obviously I'm just going back up to the previous command I run. And we can see all these options available for it. The one that we're interested in though is this mode set, which enables the driver. The default is auto, which is just, it will detect whether it's needed or not. 0 will disable it, 1 will enable it, and 2 will make it headless. And you might be sat there going, okay, but how do I apply these? Well, that's easy. All we need to do is create a file in etc modprobe.d, and we will call this nouveau.conf. So nouveau.conf. And this name here has to match the name of the driver itself, which we can see here. And I have spelt it the same, yep. And all we have to do in here is open up this file, and we simply write options. So the options we want to use, the module name, which seems weird considering you name the module what it is, but that's fine. I could be wrong here, but I'm pretty sure you can actually put multiple module options in a single file. But I think generally speaking, they separate them out, or people separate them out, because it's just easier to read, it's easier to find. We know straight away that this nouveau.conf relates to Nouveau. So what I'm going to do is type the module name, and then the option, which was mode set. And then finally, the value for the option, which we want to disable it, so we just put 0. And that's it. So it's the options, the word options, the module name, the option name, and then a value for the option. So if I write that out, we can see again, Nouveau, mode set, and the option of 0. And that's it. If I now reboot this system, Nouveau will be forced to be disabled. Now it's disabled by default anyway because I don't have an NVIDIA graphics card in this particular server. But now if I inserted one, it would still be disabled, allowing me to then go ahead and install the proprietary NVIDIA drivers if I wished. Another way that we can disable a module altogether, for example, we didn't want to use the mode set, or the mode set isn't available, in the case of, let's have a look at HPSA. So there we go. We have HPSA simple mode, use simple mode rather than performant mode. That's the only option we have. Well, there isn't a mode set for this, so how would we disable this particular module? Well, that's easy too. We can go ahead and create a new file, again in etc modprobe.d, and we call this blacklist.conf. Blacklist.conf will be read on boot, and any modules listed in here will be blacklisted and therefore not loaded. So we'll open this up, and in here we can see there's plenty already in here. These are all blacklisted by default. Now, I didn't add these. These are just part of Ubuntu. So it has a comment everywhere to show you why it's blacklisted or the reason behind it being in here. But as you can see, we just write blacklist, HPSA, and we would write that out, and that would now be blacklisted. If I rebooted the system now, my RAID system would stop working, and as a result, my system wouldn't boot because my Ubuntu installation is installed on RAID. So yeah. I'm not going to do that because obviously I want my RAID system to work, and I'm also going to go ahead and remove that Nouveau because it's not required here. So I'm just going to remove that file. But that's how we can blacklist modules or disable modules to prevent them loading on boot. So that's PCI devices and modules. Let's go ahead and move on to USB devices now and take a look at how we can interact and find out information on them. I'm going to move over to Intel NUC for the next section because I don't have any USB devices plugged into my server. So I'm going to jump over to this tab here. This has a USB device plugged into it, which is just a USB hard drive.
and I'm going to go ahead and run ls USB. So in here, we can see that we have the Linux Foundation 3 root hub, an Intel Core 1, J Micron Technology Core, which is actually my hard disk drive that's plugged in, and then another Linux Foundation 2.0 root hub. This is USB 3, this is USB 2. That's all it is. So we have a bus ID, a device ID, and a vendor device ID. I'm going to go ahead and take a look at this a little bit more in detail. I want to know a little bit more about what's... Sorry, you can hear my daughter in the background there. I'm a new dad. So we want to see what's going on with this particular device and how it's set up, what features it has, and more. To do that, we just run lsusb -v-d, and then we put the device ID or the vendor device ID afterwards. So this one here. So I'm just going to copy that and paste it in, and we have a lot of output. There's a lot of information here, and I'm not going to go through every line, but you can see here the vendor, the product type, the manufacturer, the product information there. There's a little bit more on it, and we'll just scroll down a little bit further. We can see more about the kind of thing it is. So this is mass storage or USB mass storage. We can see if it's self-powered somewhere. Here you go, device status or device status, self-powered. There it is. So there's a little bit of information it can't get for some reason. It's a very old disk inside, so it could very well just be a problem with the disk itself. I just chucked it in for the sake of this demo. So yeah, we can get a little bit more information about the USB device itself. We can also get a little bit of information in a tree format by doing lsusb -t, which will give it just a little bit more detail than lsusb itself, but you know, you may or may not want to use this. Again, you can see this is class, you can see this is wireless. This is the root hub, so the USB 2 and USB 3 ports. So there's a bit of information you can get there. We can also use the bus ID and device ID, so 001 and 003. So we can do lsusb -s 001:003, and that will just give us this. We can put -v on the end for, again, that same information that we got with lsusb and then the vendor device ID. So there's a couple of ways of getting all that information.
Now we'll move on to the /proc, /sys, and /dev directories. There's going to be a lot of information here. However, don't worry too much if you don't get what's going on. This can take time to understand, and I'm not going to be covering everything within these directories. There's a lot going on.
Every single file inside /dev is associated with a system device, particularly storage devices. So if I take a look inside there, this is again on my Intel NUC. I could do this on any of my devices and this would work. So in fact, I'll show you that. Here's the virtual machine. This is my Intel NUC, and this is my physical server. So these here, SDA, SDA-B, SDA-C, and again, we've come back over here, we've got SDA, SDA-B, and over here we have SDA, SDA-B. You can see these here. These are disks. You might have something very slightly different if you're using different kinds of disks. So for example, say it's not SATA and you're using instead the old kinds of disks that use the ribbon cables instead, which name escapes my brain at the moment. If you're using one of them, you might see something like HD0, HD1. You might also see VG something or VG1 or something like that. It can vary depending on the kinds of disks you're using. There's also SD cards and NVMe cards. In here we have MD1 and MD2 and MD0. This is because I'm using RAID on my VM. In my Intel NUC, I don't have any NVMe cards or anything like that, so you won't see that in here. And over here on my physical server, again, there's no SD cards or anything like that, so you won't see anything like that here. NVMe cards will show up a little bit different. So back onto my Intel NUC. In here we have, again, lots of information. We have information on CPU. We have block devices, which are just disks. We have standard in and standard error stuff, essentially. So this is where if I just try and cat out, for example, dev/standard error, nothing will happen. But if I had an error, then I would feed it into standard error. Same with standard in and standard out. These are input, output, and errors. So when I do something that has an error, for example, when I, on the physical server, ran modprobe remove, let's just run that again. I'm just going to search back through my stuff. So this will go to standard error. So this will be fed into standard error. And it just allows that to be read. We also have a lot of TTY shells, as you'll see here. TTY are just different terminals on the physical machine. So if I was to jump onto my physical server, this here is TTY1. So if I was to plug a monitor in, I would also be able to see this exact screen that you're seeing here. This is just a window into my server via something called ILO that exists on HP servers. This is using TTY1. I can get onto TTY2, TTY3 and more. I'm not sure if I can do it through this. Yep, there we go. Control Alt F2, 3, 4, 5, 6, 7 and so on. So we can see here, that's how the TTYs work. So if you see something like TTY, that's all that is. TTY just stands for Tele Typewriter. It's an old name that's come through from the Unix world and still exists now. I think it was somewhere in 1970 something where it was added, and yeah, it was named what it was because of the language that was about at the time, and it stuck around to now. If I have a look in dev and then block, you will see a load of numbers here. If I just print all of them out, you can see not really much information. So if I just give it a bit more information, you can actually see that they just loop back to other things. And then there's other parts we can look into, such as dev and then disks. And if we have a look in here, you'll see by dname, by ID, by label, by pot, UUID, and by path and UUID themselves. So if I just put a star on there and a -L, we can see, if I scroll back up, that again, these just link back to the physical hard disks and the partitions. If you see a number after SDA or SDB, this is a partition on this disk. So this is the disk and this is the partition number. So we can see the disk type here when we look under ID, and yeah, it's just all loops back. You can see here, every single one of them is a symlink back to the physical disks. So that's a way of identifying disks. It's a way of finding disks within a system. There's, again, plenty of stuff that you can find within here. I recommend just having a look through the dev directory because there's a lot in here, and to go through it all would take a very long time. But most of it is just related to, as I say, the devices within the system itself. So just system devices, physical stuff. So now we're going to take a look inside the sys directory. In here, there's a lot of information. I'm not going to go through every single thing in here, and to do so will take a very, very long time because there's a lot of stuff in here. But this is all related to storing device information and kernel data related to the hardware. It's very similar to those we see in proc, which we'll get into in a second. Proc, however, contains information about various kernel data structures, including running processes and configuration. And as I say, sys has the purpose of storing device information and kernel data related to the hardware. So just as a quick look, we'll take a look inside something like, let's have a look in devices. So we'll have a look in sys devices. And in here, we can see nothing really super useful, but let's have a look at CPU. And we can see some information on the CPU here. Let's have a look at power. Yeah. And yeah, you can see here, there's quite a bit of information. Let's cut out some of that stuff. So it doesn't really give you a lot, but these just define the information essentially on the CPU itself. If we have a look at something like, let's have a look at, I don't know, I'm just randomly going for this here. We'll have a look at sysclass this time. I can just have a quick gander through here, and we've got firmware stuff, graphic stuff, and GPIO stuff. We've got SCSI disks. Let's have a look at SCSI devices, SCSI devices. So these refer to the small computer system interface. These are devices that can be connected via SAS ports. So let's have a look inside here. These are my SCSI buses essentially. And within this, we can have a look at some of the disks that we're dealing with. So I'm going to have a look at /devices, and yeah, we get even more information. So you can see this is quite in depth. In particular though, something worth having a look at. In particular though, I'm just going to cat out vendor. Let's just see what's in vendor. ATA. Maybe this would be better to look at. If we have a look at the physical server, we'll have a look at sys, class. We'll go for SCSI host this time. We've got host 0, 1, 2, 3, 4, 5, 6, 7, and 8. I'm just going to look at them all. And in here, we can see this scan option. And this scan option allows us to rescan the device itself. So if we add new disks or something like that, we can do something like this. Now, this is going to be a little bit ad hoc. I'm just going to pick one at random. So we can do echo, and then 3 hyphens into that. That will force a rescan of this host. So if we've added new disks, like I say, it will pick up that new disk. It prevents the need for a reboot and things like that. Again, I'm not going to get into the details of that right now because this is quite in-depth stuff. And this video isn't a deep dive, it's just a quick overview of what exists within the directories. So again, recommend you having a look through this. There's a lot in here that you can go through. Have a look at most of the stuff. I mean, to be honest, unless you're changing something pretty major, you're going to be able to learn a lot about what's going on here. You might have to do a little bit of searching for what some of the values might mean. But yeah, there's a lot of information here, like I say, related to storing device information and kernel data related to the hardware itself. So finally, I'm going to go back to my Intel NUC and we're going to take a look at the proc directory. So in here, you'll see a lot of numbers, and then a few other words that might mean nothing to you. But let's just go through these. So firstly, the numbers are process IDs. So if I just run something like top as a quick example, you can see all these numbers on the left-hand side. These numbers, if I just grab one of them at random, will exist within that proc directory. So we can see here we've got 3320139. We have, let's have a look, 332, where is it? 3320139. And there it is. There's that process there. So these relate to those processors and have information on the actual process itself within those directories. The rest of it is, again, as I said previously when I was talking about sys, just information about various kernel data structures, including configuration and, as I've just said, running processes. So let's take a look at some of that. We'll have a look at proc CPU info. CPU info gives you, well, information on the CPU. It tells you how many threads we have running. So I have 2 on here. Tells you the model name. So this is an Intel Celeron CPU in my Intel NUC. And it tells me the speed it's running at. It tells me the physical ID of this. So this has 1. Just to give you a comparison here, this is probably not the best one. I'm going to jump over to my physical server again. And we're going to do cat proc CPU info here. Now here I have 2 CPUs running in this machine, and both of them have 12 cores each. And as you can see here, we've got a physical ID of 0 and 1. So there's the physical 1. And if I scroll up a little bit, let me just drag that up a bit for a bit of speed. A little bit further, physical ID 0. And there we go. And processor 5, processor 4, processor 3. These are just threads. So each one of these represents a thread. It tells us information about bugs of the CPU. So this is vulnerable to CPU meltdown, Spectre v1, Spectre v2, and much more, as you can see here. It's the same for this one as well. So we can get a lot of information on the CPU here. We can see flags related to the CPU. We can see if it has siblings. And it tells you how many siblings it has, so how many threads essentially the CPU has. So yeah, there we go. There's a little bit of information on the CPU info. Let's have a look at, I don't know, just again picking at random here, memory info. So we've got the total memory, the free memory, the memory available, how much is cached, how much is related to swap, and much more. So when we run free -h for human readable, that actually grabs information from this file itself and puts it into a nice format for us to be able to read. But that here is it's just coming from this file. This is where the memory information is. Again, there's a lot more going on in proc. We can get a lot more information based on modules. We can get stuff about the versions running. So if let's just have a look at that. Proc/version tells us the Linux version we're running. And yeah, much more. So I would recommend, again, just having a look, cat some stuff out, have a look at the results, and take a look around.
So let's look back at those numbers within proc. These are just process IDs and relate to running processes. That's it. We'll go ahead and do a small demo where we create a file. I will then go ahead and find the process ID for that file, find the process within proc, and then just see what information we can get out of proc that might be useful to us.
So I'm going to just give you a quick example of what I mean about these processes that are running. So if I do ls off, this is a way of getting a process ID. You'll see a lot of information come out here. Ooh, look at all that information. That's a heck of a lot of information. We can't read that. So let's do something with a little bit more sense. I'm going to go ahead and open up a new tab and SSH onto this server again, or my Intel NUC. And then we're just going to have a little play around. So over on this new tab, this is the same server. I'm going to open up Vim and I'm just going to create a test file, just called test.txt. And in here, I'm going to put hello world, welcome to Vim. And that's it. I'm also going to spell world correctly. I'm now going to go ahead and get the process ID for that. So I'm going to do, let's have a look. Probably the easiest way of doing this would be ls off, then grep for Vim. There's many ways you can get process IDs. We could use PS tree. We could use PS itself. In fact, I think PS would probably be better. I'm going to do that. So we'll just do, sorry, AUX. And here we go. Here's the process ID for that particular running instance of Vim. So if I have a look now in proc, and then that number, it gives us some information. So I'm just going to have a look at a few things within there. So we'll cat out the command line. It will tell us the command that was run. So vim test.txt. There's no white space in here, by the way. I'm then going to have a look at the environ. So this here will just give us the environment that it's run within. Or if we run env, we would get the same results. So if I do this, look, for an env, we can see here, we've got the same results. So we've got shell bin bash, then we have pwd is /root, pwd is /root. So yeah, so we can get the environment that's been run within. We can also get, like I say, a lot more information. So we can have a look at mounts. So we can see the mounts that were running at the time, essentially. This is all the mounts that are linked essentially to this. I mean, it's not what we're using for this, but it's the mounts that are active at the time when we are running this command. And we can get more information such as the file descriptors. So I'm just going to go into that. And in fact, I'll make this one of the last things I look at. Because again, just have a look through some of this. You might have to do a little bit of searching around, a bit of Googling around to find more information on this stuff. This isn't a deep dive into these three directories, it's just an overview of them. But I'm going to look at the file descriptors. So file descriptors are essentially a number that uniquely identify an open file in an operating system. So there is information on how this works, and there's global file tables and inode tables and all sorts of stuff that comes into this. But I'm just going to start off with this. We're going to cat out number 3, okay? And then here we can actually see a lot of what looks like encrypted text, but then, hello world, welcome to Vim. So we can actually see what's going on inside this text. Now this could be useful if you're trying to see what's running on a system. So if something's happening and you don't know what it is, you can dig into this further. So I wonder if I can just get a quick example of something here. So I have Kubernetes running on this system. I'm going to run ps-aux grep container. And I'm just going to grab a random ID from here. I'm just winging this, by the way, so this may or may not work. I'm just using a bit of kind of educated guesses here to see if I can figure out what's going on inside a container, or maybe what port something's running on, or more. So let's go ahead and do that. I'm just going to close this Vim here. I'm going to do sstnalp and have a look at what we've got going on here. So we've got things like kube controller here, which has process ID of 725. We might be able to relate something here, but I'm just gonna see what we can do. Let's have a look. So let's have a look in proc. I'm gonna do -l on that ls as well, just to see what's happening in the file descriptors. So we can see here we've got all these really long numbers for sockets and pipes. These are essentially, they're not ports, but they can sometimes relate to them. If I go back over here, let's see if I can... I can't get the process ID, so let's pick one like this process ID here. So this is the PID. I'm going to take a look at this one. Here we go. So this here relates to the, I've lost it already, the kube proxy itself. So things will relate back and forth. We can then do a search for example, we can use ls off here. So ls off, and then I'm going to grep for this number. And you can see here that it's given us information on the process of kube proxy. that's running within Kubernetes, and this number here has related to this number in here. Well, I've lost it. Well, I did it in ls proc, didn't I? And we can actually now see the ports that are open here, or the ports that are being used, and it all relates back and forth. So it's worth, again, having a dig round. I'm not going into a deep dive here. I probably shouldn't have gone as far as I have into this, but I just wanted to give you an introduction. And I think at that note, I'm probably going to call it a day, because we could deep dive further into this and start troubleshooting more things. But to be honest, I think it's probably worth not going too deep here. So I'm going to leave it there, and we'll pick up more in the next video.
And there we have it. Easy, right? I get you might be sat there saying, what? What has this guy just told me? I don't understand. Don't worry about it. I don't know every single element of the /sys or /proc or /dev directories. Some things in there I've just never used, and therefore, how can I tell you about them if I've never used them? So don't worry too much if you don't get what's going on in some of those locations. With time, experience comes. So give yourself a break. Have a look at the mod probe command, have a look at the lspci and lsusb commands, and have a play around through them. You can get a lot of information on your devices, as well as all the stuff I've mentioned in the video. Go and have a look, use ls-l through those directories that we mentioned. They'll show you where all the symlinks are to other things, so you'll see things linking back to devices and more. Again, don't beat yourself up too much if you don't understand what's going on by the end of this video. I'd be impressed if you got everything. You might have to watch it a few times, you might even have to look at other resources as well. But just have a look around, there's no harm in that. If I covered everything within those directories too, if I could cover everything in those directories, this video would be a heck of a lot longer than it already is. So I've said it before and I'll say it again. You don't want to sit listening to me all day. You want to go and have a look through yourself. That's kind of why you're here, isn't it? You want to learn and move on to actually doing stuff with that knowledge. So hopefully I've given you a little bit of information here that will get you in the right footing to start managing devices via the OS. In the next video, and the one afterwards, I'm going to be taking a look at booting and run levels. And then that should wrap up this first part of Linux learning tutorials. Once we've done those, we can start looking at more in-depth things like managing files and managing networks, and I don't even know off the top of my head yet. I'm going to be moving on to that. So I'll see you over in the next one. Bye.